Okay, here we go. This is a SAP 2000 version 14 video tutorial for analysis, modeling, analysis, and design of a steel truss bridge. Let's get started. File, new model. In the new model, we will go for the cape foot and select the truss, 2D truss. Now here we can have predefined types of truss. This is a slope truss. We can have a vertical truss, okay, and we can have a Pratt truss like this one. So we will go for the slope truss. Okay, number of division which we have. Number of division we have right now is how much we have? One. Just a minute. 1, 2, 3. We have 3 divisions. So we will take this default 3 division. Length of each division. The length of each division, I'll change this division to 15, and I'll keep the height as 12. Okay. Length of division mean this span length. Okay. So chords. The chords, I'll keep the chords and bracers as default. Bracers are the vertical element, chords are the horizontal elements. I'll keep this as default. Press OK. The model is generated. Now close one of the window and open this one. Now here we need to define some elements for this truss. Go to define material, and here we have a steel made up of grade 50, FY50. I need a steel of, and this is A99, so I will use A36 steel for the A36 steel, FY less for that. I'll use this for our steel bridge. Okay, so add a quick new material and select steel, and from here go for A36. Press OK and press OK. A36 has FY equal to 36 KSI. Now define section, frame section, and we need to import some sections. Import new sections, and we will select L sections, and we need to open this from the file aisce.pro, and from here select set of L sections which you want to include. I'll select all the L sections. Press OK. All the sections are imported here. Okay. Now the next step is to add a new property. This time I'll select auto section, and select all the L sections and add to the auto list, and auto L, its name is auto L, and press OK. What happened is we have defined a group of section named auto L. This section contain all the angles together in a single auto L. Okay. Now when I assign auto L section at a time, how many sections are assigned? Multiple. We have assigned tentatively from this group one of the L section. Okay. Now the program will determine itself during the design which section fit or optimize for the capacity. The program will select itself. Here we don't have a single section, we have multiple sections available. At analysis, one section is selected tentatively. At modeling and analysis, one section is selected tentatively, and during the design this section can be changed so that it is optimized for resisting the given loads. Okay. Now auto section is defined. Press OK. Now here we need to define load cases, load patterns. Add live load, change type to live, press add. Now define, we need to change the code as well, or see the code as well. Steel frame design, view revise preference, and for the steel we would like to look at the code for the steel. Okay, by default the steel code selected is AISCE LRFD93, so I'll keep this AISCE 93 LRFD93. Press OK. Now define load combination, add default design combo, steel frame design combo. So this steel frame design combination is based on LRFD 93. Okay, press OK. So we have 4 combination available with us. Record. Now in the first combination we have dead load. Okay, in the second combination we have dead and live load, just like that of concrete. In the third combination we have dead with factor of 1. In the fourth combination we have service dead and live. Okay, got it? Now save our model. I'll save this in my document, summer tutorial, and steel truss, and the model name is again steel truss SAP steel truss. ST means steel truss. Save our model. Now if we extrude our view, so we can see that we have here a single element here. Okay, so we don't need this, we need to separate it down. Okay, so we need to delete these members, this one, delete it, and go to this menu, quick draw frame, and type is auto, and make a window here like this. So each grid has a single member here. Repeat the same procedure for the top, each grid. Okay, and for the vertical just make a single click so that you can have vertical member. So now our modeling step is complete, and we can go back to unshrink view. This is a model which we need. Got it? Even the length is also okay. The vertical length is from here we can see the vertical height is in fit it is 12. Okay, and this length is minus 22.5, and this length is minus 15. So this length become, let's see, by right click we can see this one, the length is 7.5. so all the lengths are as per definition which we have defined. Okay, let's save our model. Here we have an additional member, we need to delete it. Okay, now what else we need? We need to assign, go to assign menu, select all the members, assign frame section, and go to auto section list. We have assigned auto section here. Okay, now again go to previous selection, assign. Right now we will assign the loads, joint loads. So remove the selection and select only the bottom joints. One comment on the auto list. In the auto list by default they have selected 4 cross 3 cross half. This is the angle section which they have selected. This may change after the design. Tentative selection of the during the modeling is 4 cross 3 cross half. Okay, now select the bottom joints and go to assign joint force. In the dead global Z direction will add minus 10 kip of dead load, and press OK. So a dead load of 10 is added. Go back to the previous selection and assign joint force, and go to the tab as live, and in the live add minus 30. Press OK. For minus 30 value of load is added. Okay, our model is complete for the section. Boundary conditions are defined here, loading is defined. Our model is now ready for analysis. Once again save the model, analyze, set option, and select plane frame because it is a 2-dimensional structure. Press OK and run the analysis. Remove the model because we are running static analysis. So model is do not run now. this is the deform shape of our model, and we can check the deflection value in inches, how much our model is deflected. So how much in the U3 direction it is 0.148 inches, and this one in the middle it is in U1 is U3. U3 is the vertical direction. It is minus 0.236 inches. How much this joint is rotated? It is rotated 0.00208 radians. Okay, got it. Now next step is to go for frame forces and see the axial force diagram for only live load. This is the axial force diagram for the live load. Let's see the axial force diagram for the combination of dead and live, which is UDSTL2. This is 1.2 of dead, 1.6 of live. This is axial force of diagram for the combination of load dead and live with factored. Okay, yeah, this is axial force diagram. You can see the detail value by the right click, and you can see the axial force and its detail here. From here you can change to shear force diagram. There is no shear, and you can check to movement diagram M33. So we have some movement here in the frame. Got it? Now the reason for the shear and the movement is that the joint of the truss are not pin. In SAP2000 the joint of truss are not pin. Even if I am going to look at dead load diagram from here, I am going to see the shear force for the dead load. So there is a value of shear force for the dead load, because and it may be there, and there will be a movement here. There is a movement diagram as well, movement 33, and we are looking at the movement values. Okay, because here we have negative movement at the pin, at the joint, which is not pin. In SAP2000 joints are not pin, they are taken as rigid joint in SAP2000. So if you want the joint to be pin, you have to define this by your own. Understood? And these values of movement are because we have along the span we have the dead load acting, uniformly distributed load along the span. That UDL is causing the movement here, and shear as well. If you want, unlock the model. If you want your design to be free of movement and shear, what you need, you have to follow two steps. Step 1, in the load, make the self weight of the dead as 0. We will do this again. Define load pattern, dead load, and make this as 0. Okay, so dead load will not be of self weight, will be not UDL of the self weight is not considered in analysis. And the other thing, select all the frame, go to assign frame partial release fixity, and release the movement 33. What does this mean? We are releasing the movement. The movement can be released. It is becoming a pin. If the movement is released for the joint movement 33, it become the pin. Okay, so movement 33 is released, and it is represented by the green color over here. Now the joint become pin joint, and self weight is now 0. Run the model. Now here we have movement 33 diagram, and its value is 0. Okay, and we can have the shear force diagram. Let's check the shear force. The shear force diagram is also 0. Now it is behaving like a true ideal truss, which we solve using book problems. Ideal truss. In ideal truss we have a pin joint and no self weight is considered, but practically you have some fixity in the joint. A joint is a kind of a rigid joint, so you should consider this as a rigid joint in practical point of view, and you should also consider the self weight of the joint from practical point of view. Okay, so now we want to design from the practical point of view, so I have to shift this problem back to the first case. Okay, so unlock the model and select all, define load pattern, and that is here 1. Modify and show, press OK, and go back to assign frame, uh, assign frame release partial fixity, and uncheck the M33 for start and end, press OK. It is a register frame with sulfate included. Now rerun the analysis. Again analysis is performed. Now we need to design. We have checked the forces, and the next step is to design. So go to design, steel frame design, and view revise preference, select the code. Code is already selected, load combination is based on this code, so it is already there. Now go back to design, steel frame design, select design combos. So we have two combination are already selected with factored load, and the unfactored combination is also selected here. Under the load combination is already selected for the design under another load combination type. So their combination is also selected. Dead and live are already selected with a higher factor, so we don't need the unfactored one. Okay, so we'll leave the unfactored one, and we have the factored only for the design, so it will give a good design for us. Press OK. Now go to the design menu, steel frame design, and start check design. Okay, now in the start we have the section as how was our section? Our section was 4 cross half. Now in the design the section is now changed. The section is now changed. It is no more it is now 8 cross 3 by 4. Okay, now go back to the design, steel frame design, verify all member pass. All member are passed for the capacity check. Now another check, design, steel frame design, and verify analysis versus design section. The section in the analysis were taken should match the section in the design, but this is not the case. 17 sections are different. In analysis we have taken 4 cross half, while in design we have different section. So for a complete design, analysis and design sections should match. Okay, so select the section. All sections are changed except the first two. 4 cross 3 cross half was the original section. Okay, so we need to change this thing. How we will change this thing? We need to rerun the analysis. Now analysis section is changed. Analysis is based on the new design section, and again rerun design, steel frame design, and start check design. And design is done. Now design, steel frame design, verify all member pass. All member are passed. Design, steel frame design, verify analysis was design section. Now here we have 14 member, first 15. Now 14 member are different in the from the analysis section, so you need to rerun and redesign again. Okay, so this is a kind of iterative process. Again run the analysis and go back to design, steel frame design, verify analysis versus design 10. Okay, so this thing should match. For complete design these things should be match. Rerun. Okay, and go back to design, steel frame design, start check design, verify, and this is 6. Right now we have 6 different. Okay, so again we need to run. This is a kind of array until you have match of the section. So you have to continue until it matches, and this complete the step for steel design. And the selection of section are those which are the optimized section. Okay. One thing else, we have a different section at different chords, so all the bottom chords should be the same. For simplified design, all the bottom chords should be the same, all the bracers should be the same, and all the top chords should be the same. Okay, so which one is the heaviest one? I will go for 8 cross 8 cross 7 by 8, and I'll put it throughout the top chord. In the bottom chord I will select 5. This one is the heaviest, 6 cross 6 cross 5 by 8, and I'll put it throughout the chord here. Okay, and here in the diagonal, which one is the heaviest? I have this one is 5, 3, 8, 6. The most heaviest is 8 cross 8 cross 3 by 4. So I will select 8 cross 8 cross 3 by 4, and I'll put it throughout here. Okay. So unlock the model. Go for your final selected stations. Okay. So we need to label that as well. Frame section. And we need to remove the auto from this. I'll select all the diagonals and assign frame section 8 cross 8 cross 3 by 4. In the top chord I'll select 8 cross 8 cross 7 by 8, and in the bottom chord we will select 6 cross 6 cross 5 by 8. Okay. Now we have selected section by our own. The design has helped us to select which kind of section we should have. Now here we have this is a single section. We have one thing I have noticed right now, that from here to here we have a single section. So, and there is a joint coming here, so we can replace this with a single section. Got it? So select them and edit line and join frame. So this is joined in a single element. Select this one, edit line, join frame, and it become a single member because it is a single one. Okay. Bottom is okay because we have a panel here, connecting line here, and we have connecting line over here and here only. That's why in between it should be a single. We have connected line here and here only, so it should be a single. Now here we have connected line here and here, so this should be a break here, okay. Now run the analysis. Go for unshrink, go for design, steel frame design, start check design, and go for design, steel frame design, verify all member are pass, and design, steel frame design, verify analysis versus design, analysis and design section matches. because there was no auto select. So auto select help you to choose which section should be there. It depends upon designer which section he choose in final design. So auto select give me an idea to choose which section I should use, and I have chosen a section of my own choice which I wanted to use, and I have selected it final, and I have finalized for that. So in the steel design we go for two steps: start check design. After that you have to verify all member pass and verify analysis versus design section. That's very important. This concludes the tutorial. Okay.